Hi friends, welcome to GMAT Points video series. In this particular video, we'll be taking a look at graphics interpretation. Graphics interpretation is one of the 4 types of data insights questions that come. Apart from data sufficiency, there are 4 types: multi-source reasoning, graphics interpretation, two-part analysis, and table analysis. So here, graphics interpretation is one of those 4 new type of questions that come in data insights as such. So let us take a look at what is graphics interpretation, what are the skills expected of you, what is the question format. Let's take a deep dive into this particular topic. So first we'll understand this particular graphics interpretation. What is the ability tested? What are the types of formats that are there? So in this particular graphics interpretation, 3 to 4 questions of GIA are present in the DI section, data insight section. Okay, so this is an important part, one of the 4 important parts as such. So this is you definitely need to know how to read charts, and not only just because of the graphics interpretation section, but the basic concepts of this are also part of what is asked in MSR, because in multi-source reasoning also you get charts. So basically the skill tested over here or the ability tested over here is your ability to read visual information. So visual information includes charts, diagrams, pictographs and other qualitative charts as such. Qualitative charts and diagrams. So this is the skill essentially tested. So what is visual information? See, essentially when you are being given any kind of information, it can either be given in the form of like verbal information. You will be given like a paragraph describing all the information, or it can be given in the form of a table, which is what many reports actually contain. They contain tables because it is easy to understand numerical information, but sometimes numerical information can be overwhelming. So when that is difficult to understand, or it is difficult to make a case or a point just using a table, what often is given is, instead of a table, a chart is given or a diagram is given to make a point. So if you represent some information which is numerical information in a chart form or a visual format, it is more impactful. So if you are a manager, you will be dealing with a lot of visual information, because many of the reports contain graphs, charts, diagrams, essentially pictographs to highlight certain key pieces of information as such. So the ability that is tested in the GI questions is basically your ability to read these visual sources of information. This is something that is going to be essential even as a manager, not just for this particular exam, but even when you are an actual manager, when you are an MBA student. In all of those scenarios, you will actually need the ability to read graphs, charts and diagrams as such. Now, how is the format of this question? Let's take a look at the format of this question. So I know that I'm going to get some visual information as such, but what do I have to do over there? What is the format of the question? What do I have to answer in that particular case? So what you'll be given is basically you'll be given some graph, some chart, some diagram, and below that you might be given one statement or even 2 statements, such that you have to make these statements true statements as such. True statements that the truth value of the statement is true. Now, how do you make a true statement? So this statement will have some missing information. Some information will be missing over here. Kind of think of it like a blank, and you have to fill in the blank with the right option. How do you fill in the blank? Options will be given. They will be in the form of a drop down. So you click the drop down list, then you will have 5 options or 3 options or 4 options, and from these options you have to select one value, such that by inserting this value in this particular blank, this statement becomes a true statement. I'll give you examples of it so that it is clear of what exactly will be required. But there will be essentially one statement with 1 or 2 blanks. You have to select the right option to fill the blank such that the statement becomes a true statement. Now, what are the skills tested? What are the base skills that you need to answer these questions? So the primary skill tested, or the primary skill that is needed, is obviously ability to read graphs. But before that also, there are certain skills that are required so that you can answer the questions. So the questions, the skills that are like primary or prerequisite before you even come to graphics interpretation are quant skills. So which quant skills are required? Arithmetic skills. So you should be able to understand what are percentages and rates of change. So at what rate is this changing, or at how many percent higher than, how many percent lower than, you should be able to answer that. So basic arithmetic understanding is required to answer many of these questions. Sometimes some amount of algebraic understanding might also be required, but that is not that much. Mostly it is entirely arithmetic understanding, because the answers will be of the form of what is the growth or increasing value, or what is it, it is how many percent higher than, how many percent lower than, or it can be in the form of ratios. The ratio of this value to this value is in this format. So basically mostly it will test your arithmetic ability, your ability to understand arithmetics in terms of ratios, fractions, percentages, rate of change. All of these are basically what will be tested, what will be prerequisite to answer questions of this type. Another thing that will be required is your understanding of descriptive statistics. So what are descriptive statistics? So basic statistics you would know. So all of you would know basic statistics that are required, which are like mean, median, mode of a set or of a distribution. These are basic statistics that are required for answering many questions even in quant. Apart from that, there are additional statistics that are required to answer questions on graphics interpretation. These include standard deviation. Then there is a understanding of what a distribution is, what is a normal distribution, what is a skewed distribution, what is a multimodal distribution. So this is basically an understanding of distributions. So this is the second skill that is needed, which is understanding of distributions and understanding of what is standard deviation. So other than that, you would also need an understanding of correlation. What is correlation? What is positive correlation? What is negative correlation? And what is uncorrelated? These are quantitative concepts that you need to know to be able to answer questions in graphics interpretation. Arithmetic, you should definitely complete arithmetic preparation before you come to graphics interpretation, because percentages, ratios, fractions, all of these are really needed to answer questions in GI. The other thing that is needed for descriptive statistics, that you can learn in tandem with graphics interpretation, because many of the concepts of like descriptive statistics can only be understood with the help of graphs, because without understanding graphs, you will not be able to understand what a normal distribution is, what a skewed distribution is. So this you should do before you come to GI. This you can do in tandem with your preparation for GI, because essentially it can also be understood better with the help of graphs and charts. So this is basically the prerequisites that you should have before you come to prerequisite skills that you need in tandem with GI as such. So let us take a look at the type of GI questions that are that come, and what is the types and the skills tested in each of them. So I have tried to split them up according to the different types that come. One is charts, one is quantitative diagrams, one is distributions, one is qualitative diagrams. So we will be putting these as different parts of the course. So we will take first charts, because they are the most commonly asked GI questions. This is like from most common to least common. Okay, so with that, basically you have to remember that charts are the most common. They will be, of the 3-4 questions, you will at least get 1 or 2 from charts itself. These are basically also the reason why more charts come, is because if you consider in a managerial scenario, charts is basically what you will actually be asked in a realistic scenario. You will have fewer flowcharts, you will have fewer pictographs, you will have fewer scatter plots to read. This is something that you would deal in more with when it comes to research, and this is what you will deal with more when you're a manager at a company. So this is why also in the GMAT exam you will have more of these and less of these. So we will consider each one of them as separate part. The part 1 will be focused on charts, part 2 will be focused on quantitative diagrams, part 3 will be focused on distributions, part 4 will be focused on qualitative diagrams. So let us take a look at what is each type and what is the skills tested. In charts, the basic skill that is really tested is the ability to read the chart and answer basic arithmetic on the basis of the chart. This is essentially the skill that is tested. When it comes to quantitative diagrams, it is basically the ability to solve questions based on the diagram. So it will basically be your understanding of set theory, understanding of networks and interconnection of networks, which will be needed to solve these kind of questions. When it comes to distributions, there is specifically, this relies on descriptive statistics, your understanding of descriptive statistics to answer these kind of questions. When you come to qualitative diagrams, this is mostly a reasoning base sets. It requires a lot of reasoning to solve these kind of sets. So I have described all the different types as well as the main skill tested and in each of the types. So now let us take a deep look into charts. Now let's take a deep dive into charts. So let's take a look at what are the skills tested in charts. See, the primary skill that is tested in charts is your ability to read the charts. So you should be able to read the chart plus do basic arithmetic operations to find out the required conclusion. So this is essentially this plus this will give you the answer required for you to answer the GI question based on charts. So how do you read a chart? What do you mean by read a chart? See, when you are given any chart, suppose this is the line chart for example, okay, there will be a way in which you can read the chart that is there. Every chart can be represented as a table. You don't start off with a chart actually. Whenever you are making a chart, the person who has made the chart starts off first with a table. So for example, this is the chart which is showing the revenue and profit for say 4 years, 2011, 2012, 2013 and 2014. And suppose it is showing the revenue and this is the revenue as such, okay. Then you have the profit where the profit is say higher and lower and higher as such. So suppose this is the revenue and this is the profit. Now how do you get this chart in the first place? How did somebody generate this chart? So how would they generate the chart is basically in a table they would tabulate the values for revenue and for profit, okay. So they would tabulate the values for revenue and profit and then they would say that okay, I have to now plot the chart. So instead of doing all of this, suppose I start off by first plotting the revenue. So say it in 2011 the revenue is at 16, then it is suppose at 18, this is at 20 and this is at say 30. Now I have to basically plot this chart. How would I do that? I would say that okay, let me plot the value of revenue, let me see the y-axis. So the y-axis in this case is suppose starting from say 12, so this is 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. So firstly I have to put 16, so I'll put 16 over here, then I have to put 18, I'll put 18 over here, I have to put 20, I'll put 20 over here, and in 2014 I have to put directly 30, so I'll put 30 over here. So essentially I am marking from the y-axis, for each year I am marking the value corresponding to that year. I am marking the value corresponding to that year, I am marking the value corresponding to that year, I am marking the value corresponding to the year. So if I have the table, I will mark all of these values. Then I will put a line connecting all the dots, and if I put a line connecting all the dots, I get my line chart. So this then becomes the revenue. Similarly, I will have values for profit. Suppose this is say 2, this is say 4, this is say 4 and this is say 10. Now I will need either on the same chart, if I have a lower axis, I can show it in the bottom part of the chart, or I can have a secondary axis, say that this is the smaller axis, 0, this is 1, 2, 3 and 4 and or rather because I need till 10, say this is 2, 4, 6, 8, 10. So my profit for the first year will be 2, for the next year it will go up to 4. So for the first year it is 2, for the next year it is 4, which is over here, the next year also it is 4 and the last year it is 10. So I can then draw my chart like this for profit. So essentially how am I getting the chart? I am getting the chart from the table. Now when you are asked to read the chart, you have to do the reverse. Whatever the work that guy has done while making the chart, you have to do the reverse work. From the chart you have to get the table. And the thing that you have to remember is that you do not need all of the values. You need only the values that essentially are needed to answer the question. So the ability to read the chart is nothing other than the ability to convert this chart into this table. Okay, and after you have converted into the table, suppose this value is a relevant value, this value is the relevant value. Suppose you are asked what is the ratio of profit in 2014 to revenue in 2013. What is that ratio? Then it would be 10:20, so the required ratio would be 1:2. So there will be some basic arithmetic that has to be done on top of this reading of chart to get to the answer. So this is essentially graphics interpretation, the ability to convert the chart into the table and then do some basic arithmetic operations to answer the question. This is essentially the skill that is tested. After you get the value, you have to read the statement, find out the relevant values you need, calculate, do the basic arithmetic operation and then select the right value from the drop down. This is essentially how you go ahead and solve a graphics interpretation question. Now, When I tell you, okay, you have to read and you have to convert it and you have to make this particular chart, the tempting thing to do would be to use brute force, that before even I read the statement, I'll just convert everything into a table so that there is no scope for error. I will not make a mistake if I convert everything from chart to the table. If I directly do that, then there is no scope for error, because sometimes many people make errors while reading a chart, because if you have say 2011 here, 2012 here, sometimes when you're reading, sometimes you might read the wrong value. Instead of 2012, you might read 2011 by mistake. So because of that, the tempting thing to do for many students to remove any chance of inaccuracy is basically use the brute force method. So what is brute force method? Brute force method is to see the chart and to convert it immediately into an entire table. I would suggest that is not a good thing to do. Firstly, we should understand why the chart is there in the first place. Why is a chart there? So consider a pie chart. A pie chart is basically a circle which shows the distribution of something. So suppose you have a salary and suppose you get say $10,000 in salary every month. Okay. Now, if you get $10,000 in salary, let's say we show the breakup of how you use that money. So suppose 50% of it goes towards say rent. Then another say 20% goes towards say food. Say another 20% say goes towards miscellaneous, and the final remaining 10% is say suppose your savings. Okay. So why have we used this format at all? Why was a pie chart used at all? Instead of directly giving you that, okay, salary is 5,000 rent and food is 2,000 food and 2,000 miscellaneous and 1,000 saving. Why bother with a pie chart at all? Why not just directly give these numbers as such? You can make sense of the numbers also. So why give this chart at all? The reason why pie chart is given is so that you can visualize things. So looking at this chart, just looking at the chart itself without even crunching any numbers, I can directly tell you that my rent is eating up half of my income. The rent is half of my income and the rest half is divided between like food, miscellaneous expenses and saving. So when you want to immediately make an impact, saying that, okay, I want to highlight how much, how big a component rent is when it comes to my salary, I will do that with the help of this pie chart, because it directly shows that this is taking up half of your salary. So that is why that entire chart is there. So if you have to actually say that, okay, if the chart is given and if you are asked, okay, what is the ratio of savings to rent? So without even finding out the actual values of 1,000 and 5,000, I can say that savings is 10%, rent is 50%, the ratio will be 1:5. So without doing any calculation, I can immediately figure out what is the ratio. So in many cases, the entire conversion of the chart to a table is not required, because sometimes you can answer the questions by using the basic information that is like in your face, it is in front of you, by using the chart itself. So the brute force method of converting everything to a table is something that is foolproof. It will definitely not fail you, but it is really not needed and it is not time efficient, because you also have to do this within a certain amount of time. So because this is not time efficient, I would say that don't do the brute force method where you every time make a table for every chart. Instead, use your skill. So when a pie chart is given, use the pie chart to make the conclusions. See what conclusions are needed. Only if you actually need absolute values should you calculate absolute values. If you are asked for relative values like percentage higher than, percentage lower than, ratios, you do not need absolute values, right? So then why convert it into absolute values at all? Suppose you are given a line chart, and suppose in the line chart, if you are given information for like say 4 years as such, say suppose from the first year to second year it increased like this, from the second year to third year it was flat, and from the third year to fourth year suppose it increased like this, okay? Now if you are asked in which of the years was the growth the highest, now you can, without even calculating, okay, what are the values, specific values, can you tell me which was the year where there was the highest growth with respect to the previous year? You can see there was a steep increase, right? If there's a steep increase, there is the highest growth. Many times growth is actually compared in terms of percentage terms with this as a base. But if that is not the case, in absolute terms, if absolute value of growth is asked, obviously the absolute value of growth would be the one where there is the steepest increase. And without even calculating what is the increase, year on year increase as such, I can immediately say that in this time period, there was the steepest increase. So the chart itself actually helps me answer without converting into a table. I can more efficiently answer using the chart itself what is the period in which there was the highest year-on-year increase. So all of this basically I'm telling you so that the temptation will always be there to convert every single thing in that chart to a table, or to at least convert the relevant things into a table. But the real skill, if you want to complete the entire data insight section within time, is to use the chart itself. Only if absolute values are required, absolute calculation is required, convert them into the relevant values. Otherwise, use the visual information in front of you to answer the questions. Okay. Now let's take a look at each different type of chart as such and use that chart to actually answer the questions that are given. So what is a line chart? So I have explained, I have given some examples of line chart. So a line chart is basically different points are put on a chart to represent different values across say time or across different like say different values of x or anything of that sort. So here again we have a timeline, okay, in the x value, and for each of these years, so 1965 to 2020, different values of inflation are given. So in 1965, the value of inflation was say 0. This is like the change in prices with respect to 1965 prices as such. 1965 prices, there was like the inflation was at say around 1%. From the figure, I can see that this is around midway between 0 to 2. So the inflation rate around 1965 was around 1%. So each of this line essentially represents all the points which represent that what was the inflation rate for a given year. So what was the inflation rate for 70s? So what I can do is I can draw this line over here and say that okay, this value of in 70s is along this particular vertical axis. If I consider the value on the vertical axis, it is around 6%. So what was the inflation rate in 1970s? It was plus 6%. So I can keep doing this to find out the relevant inflation rates for different years as such. Now, in this particular case, you are given inflation rates year-wise or across like continuous inflation rates from 1965 to 2020. So, this line chart essentially represents an entire table. If I did brute force, I can say that by brute force, I will say year-wise. I can say, okay, 1965 it is 1%, 1970 it is 6%, 1975 it is around 12%, 1980s it is above 14%. So, I can make this table. But the point is that that table is not really needed. What do we need to answer? You just need the values relevant to that particular period. So let us take a look at the statement first and let us find out what values are really relevant for answering that given statement. So the statement is the highest inflation in the last 10 years is X percentage of the highest inflation in the last 50 years. How do you find out the highest inflation in the last 10 years? So you have over here, you have 2020 and you have slightly beyond 2020. So it's around 2022 as such. So last 10 years would be around this period as such, right? Somewhere around this to this would be the last 10 years. Do you need to quantify it to find out when is the highest inflation? What is the highest inflation? Clearly by visually seeing this, I can see that this is the peak. So this peak is basically the highest inflation, which is somewhere midway between 10 and 8. So this highest inflation in the last 10 years is around plus 9%. The highest inflation in the last 10 years is around 9%. And this is I can visually see that is the peak in this period of 10 years as such. Now we are asked this relative to the highest inflation in the last 50 years. Last 50 years would be around 70 onwards. So 70 onwards, since this is around 2022, I have to consider 72 onwards. So around, I would say around this period onwards. Okay, if I consider this period onwards, where is the highest peak? What is the highest inflation rate? This is the highest peak, which is around 14.5. It is above 14, and considering how each of these bars are like separated, this point would be around 14.5% as such. So we are essentially asked that how much is this 9% is X percent of the inflation rate of last 50 years. So 9% is what percentage of 14.5. So essentially we have to consider the ratio of 9 by 14.5 in percentage terms. So 9 by 14.5 into 100% will be the required value. Did I have to convert everything into a table? No. Did I have to consider all the values from 70, 75 onwards? No. I just had to find out the peak. I have to compare the peak in this region with the peak in that region and find out how much is this as a percentage of that. So 9 by 14.5, how much would that value be? It would be slightly, so if I consider 14.5, this is 4.5 times 2, this would be 4.5 times 3 slightly greater than 3, 3, 2 plus 1. So slightly greater than 3 as such. So it would be slightly less than 60% as such. So around roughly 60%. Greater than 50% clearly, because 14.5 halfway mark would be 7.25, and less than 66%. So roughly I can calculate with the help of a calculator also. I can say that this would be roughly around 60% as such. This is basically where you would open the drop down, and the drop down will give you a list of values. Suppose the values given are 40%, 50%, 60% and 70%. Then which value will you choose from the drop down? Clearly the value that you have to choose from the drop down is 60%. So essentially this is how you answer questions based on graphics interpretation. See the graph, see the relevant information, identify the relevant information, do basic arithmetic operations, find out the answer, choose the correct value from the drop down, and then you will have your answer. Okay, this is basically how you solve questions on line charts. Let's take a look at pie charts. So what are pie charts essentially? Pie charts are a way of representing allocation. So if you have a salary, how are you allocating the salary? If you have, like say, 100 people working for you, what is the allocation across the different departments? So suppose there are 20 in marketing department, 10 in finance, say 10 in sales, etc., etc. So it is essentially a visual way of like showing allocation, and it adds up to this entire pie chart adds up to 100%. And this 100% is equivalent to 360 degrees, because a circle is 360 degrees. So if say this is 60 degrees, this is not 60 degrees, say this is say 60 degrees, this is say 120 degrees. So what can you say about the share of the 100%? See, 60 degrees out of 360 degrees is 1 by 6. So if this is 60 degrees, the angle is 60 degrees, that means that we are looking at 1/6 of 100%, which is around 16.67%. Similarly, if it is 120 degrees, then it will be 33.33%. So essentially, either you will be directly given percentage terms as it is given in this particular case, or you might be given degrees, which you have to use to convert into percentage terms. So if suppose instead of giving me 50%, they had given me 180 degrees. So 180 degrees is what percentage of 360 degrees? That would be 180 divided by 360 into 100%. I would still have come across and gotten the value as 50%. So essentially in a pie chart, you are given an allocation and it is adding up to 100%. You will either be given percentages or degrees. Degrees you have to convert into percentages. So this is basically the idea of what a pie chart is. Now how do you solve questions on pie chart? How do you read a pie chart as such? So let us try to read this pie chart to understand what is there in the pie chart, how to read the pie chart and how to answer questions based on it. Okay, so consider the pie chart that is given. So this gives you an example asset allocation of a typical investment portfolio and the diversification within the stock allocation. So this is your entire portfolio, for example, of which you are putting half, 50% in stocks, 30% in bonds, 10% in commodity, 10% in cash. Now this part is essentially an expansion of this 50% that is given here. So of the stock allocation, of this 50% also, there is no single stock that you are putting in. You are putting half of that in large cap, 20% in mid cap, 10% in small cap, 10% in international equities and 10% in emerging markets. So within this 50%, if I expand how this 50% is being split up, this is how that 50% is being split up. So this pie chart shows you the allocation across of a portfolio. Now the tempting thing would be to say that, okay, let the portfolio be $100,000. So that would mean that stocks have $50,000 and I will do the split later. Bonds have $30,000 and commodity is $10,000 and cash is another $10,000. This is how I can split up $100,000 according to this particular because this is 50%, 30%, 10%, 10%. And this stocks within itself I can split as large cap will be half of this. So large cap will be 25,000, half of 50k. Mid cap will be 20% of this. So mid cap would be 1/5 of this. So that would be 10k. Then you have small cap which is 10%. So that would be 10% of this. So that is 5k. In international and emerging markets are also 10%. So all three of them will be 5k, 5k, 5k each. So this international and emerging markets and small cap all are 5k each. So this is how the 50k will be split. So I can do this. I can make this table and then go to the statement and try to answer the statement on that basis. But it is really not required because you can do the same thing without creating the table. So given the given statement, if Ajay invests 500,000 according to the allocation given in the pie charts, then the amount invested in large caps is roughly. I can make this entire table, but this is not really needed at all, because what I can instead do is that, suppose he is investing 100k. How much is he investing in stocks? He is investing half of that, or 50% of X. How much is he investing in large caps? Large caps is 50% of stocks. So that is how much? This is 50% of 50% of X. So if X is equal to 100k, this is half into 100k. So that will be equal to how much? That will be 25k. So without even actually making the entire table, by using basic arithmetic and reading it, this is half, this is half, half of half. Half of half is 1/4. So 1/4 of the portfolio is in large cap, which is 25k. So use the charts as much as possible. Only calculate when it is needed. Do not over calculate. It's not really needed, and it will waste time, and you will not be able to attempt all the questions in that way. Okay. Now let's take a look at how to solve questions based on bar charts. So this is a bar chart in front of you. So what is a bar chart essentially? Each bar represents a value. So for example, I can convert this into a table. If I was converting into a table, it starts from the year 2019 and goes up to 2009, and it goes up to 2019. So this is 4, this is 5, this is 6, 7, 8, 9, 9. So this is 2009, 2010, 2011, 2012, and so on. And it is, I see two bars that are there. First is the total demat accounts and the new demat accounts. So how many total demat accounts were there in 2009? There were 16.87 total demat accounts. How many new demat accounts were there? There were 1.43 new demat accounts. In the next year, if I see it is slightly increasing, it should be around 18 as such. Next year it is slightly shy of 20, so I would say it is around 19.5. Next year it is going above 20. So clearly in 2012 it should be slightly above 20, so I would say 20.5. And then it is another slightly further, it would be around 22. Then further it would be around 23. Then further it would be slightly shy of 25, so it would be 24.5, and so on. So I can calculate exactly how it is increasing till finally in 2019, how much is the number of total demat accounts? In 2019, it is 39.3. Okay. How many are the new demat accounts? Initially it is 1.43. See, this is the other bar that we have to follow. So the height of the bar tells you the value that it represents. The taller the bar, the higher the value. So if I have to show 25, for example, in a particular year, if I have to show 25, I have to draw a bar with the height of 25 up to here. That means that this value is 25 as such. So this is basically how a bar chart is drawn, where each bar, the height of the bar represents the value that it is depicting. Now, why do you represent it in this way? Why a bar chart as such? The bar chart basically shows you the increase that is taking place. So if you have something in front of you and it is increasing in length, or you can see, oh, suddenly there is like, it has increased quite a bit. From here to here, it is like near more than double. So when I see like the length it is increasing, I can visually see that, okay, look, it is like growing so well. The number of total demat accounts are like really picking up, and they are growing at a very fast pace, especially near the end when the growth is fairly rapid. The height of the bar, or the rapid increases in the height of the bar, is showing me that the number of demat accounts are growing rather rapidly. Over here, if I see the height of the bar of new demat accounts, what can I infer? I can infer that around these years, this new demat accounts was almost flat. It was not very growing by that much. But in the last few years, the new demat accounts are much higher than they were in the middle years as such. So from the height of that particular bar, I can tell what is the value. I can tell what is the rate of change, whether something is increasing rapidly, decreasing rapidly, whether it is significant, whether it is small, whether it is larger. So the bar chart's height and the change in height shows the growth and the value that it is representing. So that is why the bar chart is used. Now you can say that, okay, I'm not comfortable with bar chart, I'll convert it into a table and then answer the questions. But it is really not needed. Let's take a look at the statement, for example. The statement is the number of new demat accounts opened in 2019 is X% higher than the number of new demat accounts that were opened in 2009. Now, do we need this entire table for that? No. So because what is the number of new demat accounts opened in 2019? This is 4.5. Directly it is given in the graph, it is 4.5. And what is the number of new demat accounts opened in 2009? Again, it is given directly in the table, it is 1.43. So 4.5 is how much, what percentage higher than 1.43. So that would be 4.5 minus 1.43 divided by 1.43 into 100%. This is the percentage greater than or percentage increase as such. So this will be how much? This will be 3.07 divided by 1.43 into 100%. 1.43 twice is 2.86. 3.07 is greater than 200 as such. So this increase is, this percentage is higher than 200%, roughly around 200% to between 200% to 220% as such. So if x is given and in the drop down we are given the values, for example, if x gives the drop down values as say 50%, 150%, 200% and 250%. Which value is closest to our required value? It will be 200%. This value is roughly around 210, but of the given value, suppose this is also there, 210 is also there. Roughly I know it should be around 200 to 210. So from the drop down I can choose 210 as such. Did I need the whole table to solve that? No. In most cases you do not need to actually fill a table. You need only the relevant values, to read the relevant values, to do basic arithmetic operations on them to answer the question. Okay, so let's take a look at the next part, which is stacked bar chart. So this is a bar chart, and in this case I had mentioned bar chart, group bar chart also. A bar chart is basically if there was only one line as such, if only total DMAT accounts were given, it would be a simple bar chart. Now because there are two columns given, it's a group bar chart, because each, this 2009, these two are grouped together, these two are grouped together, these two are grouped together. So the group of two bars tells you the values of two variables in a 1 year. So group bar chart is nothing other than a bar chart where multiple variables are there instead of just one variable. So in this case, because we had two variables, we had the two variables being shown as a group as such, group of or a pair of two in each year. So that is essentially a group bar chart where each year you have multiple variables, and for each year you will have a like I'll show that to you. So if you have say three variables, say x, y and z across say 3 years, 2000, say you have say 2019, 2020 and 2021, and say you have like x, y and z as three variables. So they will be shown like this, where there will be a group here, there will be a group here, and there will be a group here as such. So group bar chart is nothing other than a bar chart where there are multiple variables, and each variable, the set of variables, is essentially grouped together by a year or by given whatever is there along the x-axis. It is grouped into one slot and all the variables are shown together in that one slot. So this is essentially group bar chart. This is also an example of a group bar chart as such. If I had only one variable, my bar chart would look like this. So there will be one bar, there will be one bar, there will be one bar like this. So this is a normal bar chart without any grouping. So a bar chart, generally what you will see is a group bar chart. A simple bar chart would rarely come. Now let's come to the type of bar chart, which is the stacked bar chart. Okay, so consider the next bar chart, which is a stacked bar chart. What is a stacked bar chart? A stacked bar chart is a bar chart where the different parts of it, you are not grouping them in like different parts, or you are not grouping them in horizontally, you are stacking them one above the other. Now the stacked bar chart can add up to 100%, or it need not even add up to 100%. So for example over here, so suppose I will show you the values and I will show you the way of representing for each one of the cases, for example. So suppose this is 2019, 2020, 2021, and this is x, y and z. So they say this is 3, 2 and 1, this is 4, 2 and 4, and this is say 5, 3 and 2. Okay, this is the basic table that is there. Now if I was making a stacked bar chart, I would say in 2019, 2020 and 2021, instead of having that group, what I would say is that, say this is 2, 4, 6, 8, 10 and 12, 14 and so on. In the first year, the first 3 is from x. So I draw like this, this is x. Now the next 4 from 3 to 7 is y. So this is y, and the next 5, so that is till 12. So this is 4, 10 and 12. So this part would be z. So I'm essentially stacking x, y and z on top of one another. So instead of showing them as a group next to each other horizontally, instead of spreading them out horizontally, I can stack them up one after the other also, and even that is a valid way of showing the representation as such. So even I can show information like this, and what happens is that when you give a stacked bar chart like that, directly the total of x, y and z is visible. So this total is directly visible as 12. If I draw the next one, 2 and 2 and then 3, so So this would be X, Y and Z. So the total will be 7 and I can directly say that okay, this total is 7, this total is 12. So the total in 2020 was lesser than the total in 2019. So visually I can depict the total using stacked bar charts. Another common way in common use of stacked bar charts is when you have something which adds up to 100%. So for example, if I have a survey, for example, if I have a survey and I have different groups of survey respondents and I have suppose I have say asked 3 different types of people about a survey. So let's not take another hypothetical example, consider the example in front of us. So here these are the total respondents that are there. These are the responses that they have given. This is adding up to 100%. So this is the 100% of the respondents. If I consider total respondents, around 10% say that they never participate in outreach, science outreach activities. Around another 20% have said, so this is around 10%, another 20% have they said that they rarely participate in science outreach activities. Another 20% have said that they sometimes participate in science outreach activities. Another 20% has said that they 20 or more. So this would be I think 30 and this is also 30. So this around 30 and 30 have said that they participate frequently in often in science outreach activities, and finally another 10% that has said that we rarely participate, always participate in science outreach activities. I think my numbers are slightly off, but the point is basically this bar is 100% and it shows what is the split across these different across these 5 different categories. How did the respondents respond to what is their frequency of participating in science outreach activities? Either they will say never, rarely, sometimes, often or always. So that is the total sum total of how they will respond. So based on that, I can say that the total responses would be adding up to 100%. So I can show the relative distribution of these responses by using this stacked bar graph. Now, not only have they shown it for like the total respondents, but they have shown it according to group also. So, of the total respondents, how many were graduate students? How did the graduate students respond? So, I can say that from the table, around 5% of the graduate students say that they always take part in the science outreach activities, while around less than 10%, so I would say like 7.5 said that they never take part in the science outreach activities. So, again, basically, this adds up to 100%. And basically among the graduate students, what was the split of how they participated. So a stacked bar chart can also be like this, where it is adding up to 100%. So it would be basically a stacked bar chart where everything is level. There is no height difference between the different parts. All of the bar charts adds up to 100%. So even this either vertically or horizontally, it's showing the same thing. So a bar chart can be like this also, horizontal, it can be vertical also. So either way, it is showing you how the respondents have responded, what is the distribution. So this is another way, the way you actually show allocation in pie chart. This is also showing allocation of the respondents, what is the allocation as such. This is entirely percentages. So using this, I cannot really compare numbers, because the number of, like say for example, graduate students, for example, this is 7.5% and say men is say also 7.5%. Can I say these are equal? No, I can't say they are equal, because the number of men might be greater than the number of graduate students. So 7.5% of graduate students, I cannot really compare with how many of 7.5% of men, unless I know how many are there in each group as such. So basically in this particular scenario, the allocation within a group is given. So that is basically what we can infer about. So how do I read this particular chart? So let's take a look at how you can actually split this. So you can take this and you can write down the table, and in that table you can say that okay, total respondents 7.5% said that they never take part. Another like say 22% said that they rarely take part, or something like that. I can make that entire table, but it is really not needed, because of all these values, only 2 to 4 values are really relevant to answering the statement. So let's take a look at the statement and find out which values are relevant to answer the given question. So the question that is asked is, the percentage of graduate students who at least sometimes participate is X% higher than the percentage of tenure track professors who rarely or never participate. So consider graduate students, okay? What is the percentage of graduate students who at least sometimes participate, okay? So consider this. So rarely, so sometimes start somewhere from here. So this is 10%, 20%, 30%. So this is somewhere starting from here as such. So this is starting around, if this is 30 to 40, this looks like around 33 as such. So this is around 33, which would mean that 60% at least participate sometimes. 33% either never or rarely participate. This part is around 7, the remaining part is rarely. So if I consider in that scale, if I see that this is the 30% line, this is around 33% as such. So the number of students who participate sometimes is around 67%. So this is 67%. The percentage of tenure track professors who rarely or never participate, what is that value? Consider the tenure track professors who rarely or never participate. So tenure track is over here. The number of tenure track who participate rarely or never, this is this part over here. This is never, this is rarely. If I add it up together, I come around here, which is around 35, midway between 30 and 40 as such. So this value of tenure track professors who rarely or never participate is around 35%. This value is 67%, this value is 35%. So we are asked how much percentage higher is this percentage versus that percentage. So this is roughly double, it is less than double. So if the given options are there, okay, so if you have different options that are given, you will say, so options are say 70%, 80%, 90% and 100%. The given value is somewhere around 90%. So from the drop down, I would calculate properly, but from the drop down, I can say that it should be somewhere around 90% as such. So the correct answer in this case would be around 90%. So this is basically how you solve questions on stacked bar charts. The last type of chart that we'll take a look at is a histogram. A histogram looks similar to a bar chart. So what's the difference between a bar chart and a histogram? A histogram is basically a bar chart which shows a distribution. A distribution is basically the frequency of how many times something comes. So the number in a histogram, the height of the bar chart, it does not represent a value, it represents frequency. Always it will represent a frequency of how many times this particular value has come. Basically how I can read this particular histogram is that this chart shows that between 18 to 24, the number of respondents were 350. Between 24 to 35, the number of respondents were 520. Between 35 to 45, the number of respondents were 420. So this basically shows you the frequency of how many times this X value occurs. The X value is essentially the value, and the height of the bar chart shows you the frequency in which how many times that value occurs. Let us understand with the help of actually trying to draw a histogram. If you draw a histogram, you'll understand how to read the histogram. So consider if I have a set, suppose the set is say 4, 3, 2, 2, 1, 5, 7, 8, 4, 6, 7, 2. Okay, this is my set. I want to draw a histogram of this set. So I will basically draw all the value, write the values that are there. The different values are 1, 2, 3, 4, 5, 6, 7, 8. These are the different values that are there. Now the histogram will show you how many times a particular value occurs. So 1 occurs once, so suppose this is 1, 2, 3, 4, 5, or I can put them slightly further apart. So this is say 1, 2, 3, 4 as such. How many times does 1 occur? 1 occur once. So basically the height of the histogram would be like this. So I'll cross this off. How many times does 2 occur? It occurs 1, 2, 3 times. So my height of the histogram over here would be 2, will be 3. So this is how many times 2 occurs. What is, how many times does 3 occur? 3 comes only once. So again I have to draw a histogram like this. How many times does 4 occur? It occurs twice. So I have to draw a bar of height 2. How many times does 5 occur? It occurs only once. So I have to draw a bar like this. How many times does 6 come? It occurs only once. So again a bar like this. How many times does 7 occur? It occurs twice. So I'll draw a bar like this. How many times does 8 occur? It occurs only once. So I'll draw a bar like this. So this histogram tells you the frequency of how many times this X value appears in a particular set. Now consider the histogram that is given. We are given the number of respondents and the age of the respondents. So of the respondents, how many were of the age between 18 to 24? Number of times where the age is between that 18 to 24, how many times did that come? It came 350 times. How many times did it come where it was the age was between 24 to 35? It came 520 times. So over here a histogram is basically a bar chart where the height of the bar chart represents frequency. It represents the number of times some particular value that is along the x-axis has appeared in a set. That is essentially a bar chart with a specific, very specific use case as such. the height of the histogram in the height of the bar represents the frequency as such. That is essentially a histogram. So now that we have understood what a histogram is, how to draw a histogram, let's take a look at the given statement. So the statement asks us to answer that the number of respondents above the age of 55 are X% lesser than the number of respondents below the age of 24. So how many respondents are above the age of 55? Okay, so this is my cutoff limit. So above 55 is over here. How many are above 55? Let us consider the frequency. It is 180 and 100. So the number of respondents above 55 I see are 180 plus 100. This is the frequency of those who are above 55. This is equal to 280. What are the number of respondents below the age of 24? So my 24 is over here. So below 24 is just this one bar, which is 350. So below 24 is 350. So we are asked how much is this percentage lesser than this as such. So that would be basically 350 minus 280 divided by 350 into 100%. So that is how much? This is 70 by 350 into 100%. So that is 1 by 5 into 100%. So that is 20%. So this is 1/5 or 20% lesser than 350. 280 is 20% lesser than 350. So from the given choices, we have to select 20%, that the number of respondents greater than the above the age of 55 is 20% lesser than the number of respondents lesser than the age of 24. So basically you have to do these basic arithmetic operations, read the graph, do the operations to get to the answer. So this is how you answer questions based on histograms. This is a basic understanding of each of the chart types, okay. Each of the chart types has been covered, but to understand them in greater detail, you will have to solve a lot of questions in that, because then the difficulty level will increase with each question. So after you have done this particular video, what I would suggest is that take a look at the questions on graphical interpretation, specifically from charts. So we have a lot of questions on graphical interpretation on gmatpoint.com. So please do take a look at that. We will be explaining all of them in the video also that is accompanying the question. So this is the basic understanding of each chart. Beyond that, you have to solve different types of charts, different difficulty levels of charts to get a deeper understanding. So please take a look at this video, and please also try the questions that are there in the concept test which is attached to this particular video. So this is basically how you solve questions on histograms. In this video, I have covered all the basic concepts that are needed to answer questions on graphics interpretation when it comes to charts. In the next video, I'll be covering qualitative diagrams, quantitative diagrams, and distributions. Please keep watching for the remaining parts. Thank you.